So we're going to start looking at playing cards. Playing cards are pretty popular when doing probability problems. So there are two colors, black and red. Two colors, black and red. And there are four suits. Four suits. So you have the diamonds, which are red. You have the hearts, which are red. You have the spades, which are black, and you have the clubs. The clubs are those little shamrock-looking things. Those are black. You have an ace. There is no 1. Then you have 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have what are called your face cards. The jack, the queen, and the king. The jack, the queen, and the king are the face cards. Turns out there are a total of 52 total cards in a standard deck. And there are 13 cards. 13 cards for each suit. So 13 clubs, 13 spades, 13 hearts, and 13 diamonds. So we want to do some exercises where we calculate probabilities of drawing a card from a deck. So here's the problem. A card is randomly drawn from a standard deck of 52 playing cards. Determine the probability of getting the following. So first of all, what's the probability of getting a diamond? That's what we want to figure out. So the probability of getting a diamond, let's write down. Probability of getting, I'll just write the word diamond here. So first of all, you count out how many total ways can you get a diamond? How many total ways can you get a diamond? Well, there are 13 diamond cards, right? So 13 ways to get a diamond. Out of a total of how many different possibilities? 52, right? 52 cards we could have selected from. So 13 out of 52, and that's the same thing as 1/4, right? Or you could say 0.25. So the probability of drawing a diamond is 0.25. Let's go down. How about the probability of getting a face card? That's right, probability of a face card. So what we want to do, we want to figure out how many face cards we can possibly select from. So how many ways could we get a face card? Well, let's see, there are 3 types of face cards and 4 suits, right? You have the jack, the queen, and the king, and you have 4 different suits. So that's a total of 12, right? 3 times 4. 12 different face cards here. Okay, so that's a total of 12 face cards out of how many total cards we can select from? 52. Let's do 12 out of 52. Just divide that in our calculator. It's not working. There it goes. Probability of a face card. 12 divided by 52, what is that? It's about, I'm going to take the 3 decimal places, 0.231. And then we're doing odd cards. I want to find what the probability of drawing an odd card is. So I'm going to find out how many ways could I pick an odd card. So odd cards are like 3, 5, 7, and 9, right? 3, 5, 7, and 9. So 3, 5, 7, and 9. There are 4 types of odd cards. And there are 4 different suits. That's a total of 16, right? 4 times 4 is 16. So 16 ways to draw an odd card out of a total of 52 cards. So 16 out of 52 is your probability for drawing an odd card. Let's do that. 16 divided by 52 in our calculator. probability of an odd, we're going to take the 3 decimal places, 0.308, 0.308. Okay. How about probability of a red card? So how many red cards are there? Well, you got all your hearts and all your diamonds. That's 13 and 13. That's 26, right? 26 out of a total of 52 cards. You take 26 divided by 52, and you get 0.5. Right, half of the cards are red, so yeah, it makes sense. You get a 50% chance of getting a red card. Finally, probability of not getting an ace. Probability of not getting an ace. Let's make that one purple. Not an ace. So not an ace. Sometimes you'll see it written this way. You'll see it probability of ace with a bar. That bar over top means not an ace. So it's the complement of an ace. So everything else except the ace. So how many cards are there besides the aces? Well, if you take all the cards, right, there are a total of 52 cards, right, and subtract the 4 aces, you'll have what? 52 minus the 4 aces. That's going to tell you how many cards that are not aces, right? All the cards, 52 minus the 4 aces, out of a total of 52 cards. So that's going to be 48 out of 52. Let's do that on our calculator. 48 divided by 52. You got about 0.923. Almost a 92% chance, approximately, of getting something that's not an ace. I should probably be using the squiggly marks here to say approximately. Right, this is not actually equal, it's approximately. All right, so that's a beginning on probabilities with cards.